Hey everybody, welcome to SigNoz Launch Week. Today we have with us Vikrant and we are launching a completely new revamped tracing system. This is a tracing system which is first in the industry where you can now load up to 1 million spans in a single trace. And we have done a lot of engineering to make this possible, and Vikrant will be talking to us about that. This is something which we have been hearing a lot from our users and our customers, and there are many specific use cases in the industry which need such a system, and that's why we decided to build it. Welcome, Vikrant, and would love to understand more from you how you went about this. But maybe first we can start with a quick intro and demo of what we built.
Sure, Pranay. Hi, everyone. Welcome to the launch week. So, we started building this feature a while back. We heard a lot of requests from our community members, our users who had multiple use cases where they wanted to visualize a very large trace. We were very excited about building this. A lot of research went in what to do, how to do, what are the limitations of browser, what are the limitations of our system, what are the limitations of memory or CPU that comes into the play, and a lot of research went into it. But finally, today is the day we are launching it, and we're really excited for it. Let me just quickly show you what we're talking about, and then we'll probably dive deeper into what goes on. So this is our Trace Explorer page. Let us open our trace and see. You can see this, we loaded 100K spans very quickly in our product, and the UI is as smooth as it always was. And let us quickly see some other functionalities as well. And let's say maybe you are interested in a particular span. Maybe you, in the span number 6600, maybe you're doing something very critical. Let us quickly navigate to that span. And you navigated to your flat span 6600. You can visualize certain details. What are the attributes of this particular span? Plus number 6600, maybe something critical was happening here. You can see certain events if there were any events in this. You can filter on certain events as well, which are important to you or you are interested in. And very interestingly, now if you just keep scrolling through it, you'll be able to dynamically fetch you'll be able to see your entire trace without any obstructions. Should be able to visualize everything.
This was very interesting that you are like able to load all these spans even without loading icon coming in. Is it because it's preloaded or?
No, Pranay, there's not preloaded. So this is where our engineering expertise lies in. So what we do is we just always load a very particular set of spans, and we dynamically fetch the other spans in the background for the users, so they're able to navigate easily through our system without feeling a lag in the system. And we are not overloading our browser with such huge data so that your browser system doesn't hang. So it was very interesting where your browser limitations lie, where our system limitations came into the picture, and how we went around with both of them into the play, and we were able to deliver this. So some certain small features I'll also want to highlight is maybe you have a very huge span name, and we implemented this resizable area as well, so that you can easily read around your span names, adjust your timelines. You can see that timeline dynamically adjusting its scales as well. And very interestingly, this is my favorite part, is that our flame graph and the waterfall models are always in sync. So you always know where your particular span lies in the bigger picture. So this is our trace details page, new trace detail page with 100K spans loaded right in front of you right now.
Nice. I think I've seen a lot of products and even earlier version of SigNoz struggle with like 20, 30K spans. So this is very interesting to see that it's just so smooth and seamless with even 1,000 spans. Though I must say these seems like some test spans which you said, but I'm assuming they should work even in bigger and like actual spans which customers have.
Right. This just a visualization span right now, but this is as good as the actual data. So every span has enough number of attributes, and we have enough number of spans as well. So there's quite good representation of the actual data as well.
Got it. So this seems really interesting. Talk to the audience maybe about the use cases which inspired us to work on this. Are there like specific industries where this type of use cases are more important? Why they are so long spans? Because a typical span generally in a microservices world will have like 40, 50 or maybe 100, 200 spans, right? And that's essentially the number of hops a typical request takes. So where such use cases become important?
Right. So talking about the first use case, let us take the finance industry. Let us take people who are into the trading, the products who are building real-time trading platforms or high-frequency trading platforms. There's a, we have seen use cases where where they generate such kind of traces with huge spans, with huge flat spans particularly. And let me talk about a very common use cases. Let's assume that you have a high-frequency trading platform and 9 o'clock or 9:30, let's say Indian markets open. So right before that, or maybe right after the Indian markets open, you want to sync the market price of every stock that you have, that you offer to your users. So we have seen certain use cases where people start with a messaging queue, they insert a task in their messaging queue, and the aim of that task is to refresh all the stock prices asynchronously. So as you can see, if there's one span, flat span 6072, let's assume this is one task, which the aim of this task is to refresh the stock price of stock number 6072. So what this particular span will do is maybe it'll hit an external HTTP request, fetch the latest stock price, update it in the DB, show it to the customer, show it to the users. So it does a certain set of work. And now, as you started with, it's a high frequency trading platform. So every second of latency, every millisecond is very crucial to you. You cannot lose out on time there because the price differences become huge when you place such bulk orders. So they have very critical use case of analyzing such things. And maybe let's say they were typically interested in stock numbers, security 6600. They can quickly navigate to that, see, okay, what were the latencies in it. They can navigate deeper down into this as well so that they realize where their system's bottleneck is currently. So this is one of the use cases that we're seeing in the market that is very popular with frequent.
So is it applicable to like background processes in general? And like what a specific type of background processes? I think this is an example of a background process which you sort of mentioned, right?
Correct. It's more or less applicable to every kind of background process which you initiate a process and that process internally initiates another, maybe a million smaller processes which does the same task but for a different set of attributes. Let's say in this case it was securities, like the same task for maybe 100 securities or maybe 1,000 securities. So any kind of background job which initiates another set of asynchronous tasks, this system is very useful to you and you'll be able to drill down deeper into it as well.
Got it.
And like adding on to this, assume that this is your background task. This was your starting of the whole process. You inserted into a messaging queue. This becomes your trigger, which launches another 100K smaller subtasks. The aim of each task was to update the security. So this kind of visualization or this kind of processes are very helpful for the system is very helpful for these kind of processes.
And why can't this be done through logs? Because you can also log for each, like send to your use case, you can send us log for each security getting processed. So why take the effort of doing this in spans and then trying to visualize those things?
Agreed. That becomes a very de facto choice. Like, let's say you have 100K securities or you have 1,000,000 securities. You'll naturally assume, okay, let me just put a log line for each one and I'll be easily able to navigate through it as well. I'll be easily able to run aggregations on top of it. But assume the case, let's say, since we mentioned that you're building a HFT system and this one single span right now, there's just a single span right now, but this might not be a single span in the actual scenario because you'll be interacting with other systems. You'll be interacting with some remote systems from where you'll be fetching the actual current stock prices. You'll be updating it to your systems as well. Maybe you'll be pushing it to another Redis queue, or maybe you'll be storing it in the DB as well for a persistence as well. So it's not just a single operation. A log line, let's say you log it. You'll log either in any one of the service, or you'll log in the final service that, okay, this was the stock price and I received it at this timestamp, and you'll just log a single log line. But what was the hierarchy through it? Maybe your remote read had a latency in it. So those things do not become very clear in a log line. Log line is just a flat structure. If you create a trace out of it, if you create a span out of it, you'll be able to see, okay, this request originated at certain time, and after that there was some time taken by the remote read service, there was a latency in it, and then there was an update to DB. Maybe if you see that this latency has increased significantly, that it might cause performance issues to you, you'll go ahead and fix that latency. So using tracing for this use cases where in-depth analysis, where the whole path of the request becomes very critical, it's generally useful to have trace instead of logs. And traces also gives you nanosecond and millisecond precision as well. So we all know how crucial those microseconds, those nanoseconds becomes when money gets involved.
Is it fair to say that any system which is like very latency dependent, as in where latency is very crucial, is a good use case for like doing this through traces rather than through logs?
Right, where every service or every path that your request takes becomes very critical to you. Want visibility into where my request is going through, why it's spending certain time. Tracing becomes your savior. We have a very interesting use case of what we solved with traces. So we were doing certain kinds of works in our internal system as well for provisioning. So what we saw was we had a request which took 10 seconds. So that was the alarm for us. Okay, why this certain request is taking 10 seconds? It's not even doing that kind of a work that it requires such huge time. So what we saw is the flame graph quickly helped us visualize, okay, there's a span at the starting, let's say 5 millisecond mark, and the other span was at maybe a 90 millisecond mark. So we were losing out on time between the consecutive spans. So it very easily, we saw that, okay, we are wasting a lot of time in certain operations in the middle. And we quickly understood, okay, this was our exponential back off for the retries that we put, and the time was huge. So that was making the request suffer for a very longer time. So it gave us very clear actionable items. Okay, dude, you need to reduce this particular exponential back off. Navigating to this particular span helped us realize, okay, this span number retry count was 2 or 3. So we need to fix this. So see, you can easily navigate from here as well. I click 1695 and you can see the details of span number 1695.
Even on clicking the top span, you can like...
Yes, you can navigate easily from a waterfall, from a flame graph to a waterfall model.
Interesting. I think we're also chatting about like a good use case being in the games industry. Can you talk more about that?
Right. We had a very interesting community user as well, who was interested in this particular use case. So gaming industry, again, latency becomes very important. Your ping rate becomes very important. Nobody likes a laggy game. Everybody wants a 60 FPS very performant game. So what the use case was, the person was trying to set up a connection with the SigNoz server. Like once a connection is set up for every user on a gaming platform, they start a trace, and all the certain network events, all the user interactions that happened after that connection were logged as a part of a trace. Like all the spans in the trace belong to certain user interactions, belong to certain network requests that went through it. Maybe certain physics model was running in the background that was doing some calculations based on the user request. So all of those data got logged into spans into the trace, and assume that it's a 5 minutes game and you have a 60 FPS frame rate. So it generate huge amount of data. So navigating, visualizing that data, and again solving the smaller latencies in the system becomes very critical for gaming as well. So that's a very nice use case of gaming that could be very well solved with this.
Yeah, and like even in gaming, I think latency is super critical because the player experience depends a lot on how fast things are moving and interacting. So, and it's like, as you mentioned, it's a very high data rate, frame rate scenario.
Right, correct. Nobody loves a laggy game.
Got it. Cool. So this sounds very interesting, and I hope our users will like it. Talk to a bit about like what were the technical challenges we solved in this, or like how we thought about this from a technical perspective.
So it was very interesting technically to start with. So it's not just your system into the play right now. You have a very critical part in the visualization is your browser. Your browser has certain limitations. You cannot just blindly send 100 GB of data or 20 GB or even 5 GB of data to your browser via a network request and let the browser handle it. Your browser will go crazy and your page will become irresponsive. So that was one of the key things that you need to keep in mind to build such kind of system is your data should be broken down into certain chunks so that your browser doesn't go crazy. Your main JavaScript thread doesn't get blocked for long so that even if you send decent amount of data, even if the browser is able to handle it, you never should really process anything on top of data because your JavaScript main thread will get blocked on it. And if you see certain interactions of this scroll, you'll see very jittery behavior in those things. So that was one key thing that we kept in mind. And the second interesting part was traces is not a flat data structure. It's a tree data structure. So how do you paginate? How do you break down a tree data structure into smaller chunks becomes very critical. So certain kind of engineering work went into how you can maybe flatten the structure or how you can keep track of offset so that you can break down this data into smaller chunks as well. Those are some of the key highlights of where our thought processes went into.
Got it. Got it. That's very interesting. I think we should do a more detailed technical post also on this. Like, I think this seems like a very interesting engineering challenge. Um, but yeah, what's next in this? Like, what are the roadmap items? What are the next things which you are working on improving this trace page?
Right. So our goal was now that we have set up our base, now that we have a system in place to do a lot of things, our immediate first goal would be to add the support for span events, maybe show those span events in the timelines for easy grasp for the audience. Okay, this is the timeline. A certain request spanned from this time to this time. Maybe certain events happened at certain intervals, so that flame graph and the waterfall becomes even more intuitive. You are upfront able to see where your span event lies into a timeline. Maybe after that, our next immediate goal would be to introduce span links, linking of spans across different traces. Like maybe this trace generated another trace, which so how are you able to navigate from this trace to the second trace? Those links becomes very important. And then we'll be adding a couple. Right now, we just added a exact time per service for a particular trace. We are interested more in P90, P99 percentile as well of a particular span. If this is an outlier span or not, maybe more analytics on top of it, which gives you enough data to consume on a high level view, but gives you enough opportunities and even enough capabilities to dive deep down into those outliers as well.
Got it. Got it. Yeah, I think more detailed analytics based on like different drill downs might be very interesting to get like more insights on traces. Yeah, I think this sounds pretty interesting. I am very excited to see how the community and our customers use it. And thanks for building this. Well, I think this is sort of a first in this domain where we are able to now, and I think load 1 million spans. And I think from the architecture explained, it's not limited to like any number of spans as of now. At least as of now, we have just tested till 1 million spans, and that's what we are talking about. But yeah, this sounds very interesting. Any last words or comments?
So yeah, we would love feedback on this. We built something for the community. We're really excited to even innovate on top of it. Maybe improve this on the period of time as well. Any new features that users want, any certain use case that you're trying to solve through it. We would love to hear anything from the community. Do reach out to us on our Slack community. Happy to hit there, happy to engage, happy to ideate together as well.
Yeah, or even if you just like the feature, you can tell that. That would mean a lot to us.
Definitely.
Cool, Vikrant. Thanks for chatting. Yeah, see you soon. Bye.